Hello, this is Denton Yoder, instructor for BSE 2304, the Biological Systems Engineering CAD class. Today I want to talk about taking our survey information from the last two labs and creating a fieldbook file and making a drawing from that. The first thing I'm going to do, though, is I'm going to start a new civil drawing using my template. Oops, I forgot to use my template, so I got to add my layout to it. Maybe I should just go back and start over. Kill this. Yeah. Start a new drawing. File. New. Use my civil template. Now I have my description keys and I have my layout. I need to set up my settings so that I'm in the NAD 83 South Zone feet. So let's see, USA, Virginia. NAD 83, South Zone feet, and I need to insert, actually not I for insert, I'm sorry, the map pull down insert, image insert. I want my Mr. Sid for this area. If you go to the Blacksburg Maps, 9621_11 is the Mr. Sid for this area. Zoom extents. You should be looking at Strubles Creek. Okay, this is where we surveyed. That should be a good place to start. Zoom out a little bit. I'm not endorsing any particular teams, but I went into one of the teams' files and read their setup information for two different things. When they laser leveled lab, when they did the laser level lab, they checked Blum and Loganathan, and for Blum they got 7.86 and for Loganathan they got 5.85. Well, I have the real Blum information. I already gave it to you in your file. There was a Blum JPEG, but Blum's elevation was 2022.15, and if I add the 7.86, I come up with 2030.01. Well, I double-checked that by checking Loganathan, which was 2024.19, and added the 5.85 that was surveyed, and I come up with 2030.04. So I'm within 300ths of the two different elevations. I'm extremely happy with that. Blum was closer, so I'm going to just round up 1,000th and come up with 2030.02. Using a height of instrument on Tuesday's lab of 2030.02, I can then read their pin 1, and I took their pin 1 measurement and I was able to get what the ground elevation for their pin 1 was, calculated down from the height of instrument. Having that, I still don't know where pin 1 was, but in their first survey setup from Thursday, they shot Loganathan and Blum in their survey, and I know in the notes I'm following, Loganathan was 137.985 feet from where they were. Well, I know where Lothanagan is, so if I draw a circle and Loganathan's X coordinate is 10,922,192.152, and its Y coordinate, or northing, is 3,611,322.059, and the circle that I'm drawing from that, they surveyed it and said it was 137.985 feet away. So that is showing where their tripod is set up. But I also need to put a circle on Blum. Blum's coordinate X is 10,922,192.152, and its Y coordinate is 3,611,322 322.059. No, I'm sorry, that's Loganathan. I'm doing Loganathan again. Back up here. Blum. X coordinate 10, 922, 185.341, comma, Y coordinate of 3,611,484.622, and the circle for Blum, they surveyed it at 114.5. So what that tells me is they were either set up down here in the creek or they were set up here between these trees. I'm going to bet it was this spot. If I check the intersection, actually let me do ID. ID the intersection of these 2 points, the computer says that their pin number 1 is really a Y value of 3,611,425.545 and 10,922,423 is good enough. Okay. And I measured the Z of that spot by going to their earlier survey with the laser and adding in their, or subtracting their rod reading from the laser height of instrument to get the Z. So now I just need to go to a text file and key in an NEZ for Blum and an NEZ for Loganathan. Point numbers. What point number should I use for Blum and Loganathan? It really doesn't matter. The point numbers I've used so far is I've used the 100s through the 600s as my 6 cross sections. I would suggest that we use 1,000 for our pin 1, 2,000 for pin 2, and 3,000 for pin 3. Any points we shot from those points would either be labeled what they are if they were the cross-section pins, like 100 or 199, or label them in the 1,000 range so that we know they came from survey when we were set up on 1,000. But whatever. So I need to put my 3,611,425.545 for the northing, the easting, the 10,922,283.423, and the elevation I calculated is going to be 2025.05, and that is my I'm going to call it a TS for turn station, pin number 1. And on Blum and Loganathan, I'm going to put a BM in front of it for benchmark, because my description keys will take those benchmarks and put targets on those points so they look good on the drawing. So now I could put in here units, feet, degrees, minutes, seconds, but I'm pretty sure that's the default. But the thing I do need to do in here is set up my instrument. So I want to do a station on 1,000. I zeroed my prism so I can use a 0 for the height of instrument. And then I want to backsight. And in this one, they actually backsighted Loganathan, so I want to backsight 11. Now, if you hit it as a 0 angle, that's what you were supposed to do to zero the gun. In this one, they didn't hit it exactly right, so I'm going to put the angle in that they actually backsighted it at. And we zeroed the prism height, so I can turn that off. That's all I need for a setup. And really, I can leave the units stuff off because that's the default. So I've got my benchmarks in. I established where my 1000 point was. Now I can set up my turn station on 1000, set up my back sight, set up my prism, and I'm ready to do a whole pile of ADVAs. So in the one I'm reading, the first thing they did was shoot a couple of the pins from the cross sections. So they did an ADVA 199, 141.1031 is my angle, horizontal angle. My distance 70.265, and my zenith angle 91.5804, and that's degrees, period, minutes, minutes, seconds, seconds, and that is end cross section 100. ADVA, it did a 299, 131.3434, 65.775, 92.1417, and that is end cross section 200. You can put a blank line in here if you want. You don't have to. It's up to you. I'm going to just shoot a tree now. 1001. Excuse me. ADVA 1001. 183.0241. 15.79, 88 degrees, 5502, and this is TR for tree, 4-inch pine. Inch is going to kill my inches, kill my quotes. I guess I'll just have to put a 4. Okay. And you'll type in all the points that you shot for that survey, and the very last one will be an ADVA. You're shooting pin 2, which is going to be called 2000. I don't have their information, but you type that in. Once you do that, you're ready to set up on station 2000. And back sight 1000, and you're ready to ADVA all your shots from station 2. When you're done, you shoot 3000, you set up your station on 3000, you back sight 2000, you do all your points from shot 3, and that's how you enter the data. When you're done with all that, we are going to do the cross sections as if we were surveying them with the total station. The way we're going to do that is when I'm done with all 4 of my setups and that loop is all closed, I'm going to do a station 100. And for the height of instrument, I'm going to have you take your rod reading and subtract it from the height of instrument for our laser and put that in as the height of instrument. So that would be my 2030.02 minus whatever my laser reading was on station 100, and that's what I put in as my height of instrument. And we're going to back sight 199, so it's as if we're setting the instrument at the beginning of the cross section and backsighting at the end of the cross section. And then we can AD VD, angle distance, vertical distance. And we're going to say I'm going to 101, and I'm going to do a horizontal angle of 0, and I'm going to do a distance of whatever my tape measure distance was, 2.3, and then vertical distance, I'm going to put a minus sign, and the rod reading you read, which was like 6.23, and it's going to be a GR shot. So you're going to have, 10 or 20, whatever you did for your cross-section, ADVAs working across that cross-section. And you'll do that for all 6 cross-sections. Once again, it'll be station and 100, 200, 300, 400, 500, 600. And then after that, you need your height of instrument, which is the ground height at point. No, I'm sorry, that's not the ground height. That is actually our height of instrument. So that would be 2030.02, because that was our HI from the Tuesday survey. So it'll be station 100 in the height of instrument, backsight 199, and a pile of ADVAs. Excuse me, ADVDs, angle distance, vertical distance. And that'll let us do, all of the angles will be 0, because we're going in a straight line, a distance, which was the measurement on our tape, and then a minus sign in our rod reading, and then quotes around what that point is. And that will import all of your data as a field book. All right, thanks a lot. That should do it. Bye-bye.